Alright, this is take 2 of this video. I don't know where it went, but this is the second one. Alright, we're going to learn about the intro to the trig functions of the angles. Here we have a triangle. Let's say it's on the coordinate grid. We have r, y, and x. You can stop and screenshot this to see all the trig ratios, but it's just like the usual sine, cosine, etc. Reference point, a couple things about them. They're positive, always positive. And it's always determined by the terminal line, by the x-axis. You're always seeing where the terminal line is. So it's either the left side or it's the right side. And you're trying to see which one's closer to the x-axis. Meaning, you're going to be subtracting by 180 or 360. Those are the two only things, because it's only according to the x-axis, not the y-axis. You're looking to see what angle is closer to the x-axis. Example 1, they just want you to find it. There is an easier way, and you do have the chart in front of you, but let's say you do want to know how and why they got these trig ratios. There is a way. The first thing they do, they always refer to the reference number. The reference number, let's say cosine of 135 is this symbol right here. The other side, so you're looking at your terminal point, you're trying to see, is this terminal point closer to the 360 down here or the 180? And the answer is the 180. So you subtract the 180 minus that angle that you have, and you get 45 degrees. Cosine, remember, it's in terms of cosine, sine. So cosine is your x-coordinate. If you find the cosine of 45, if I can find it here, oh, right there, is radical 2 over 2. And if you notice here, cosine of 135, so you always look at your reference number for the original root, which is radical 2 over 2. And then it's in the second quadrant, so you're focusing on the second quadrant. Here, only the sign is positive and everything else is negative, and that's how you get your negative radical 2 over 2. Also, if you look at cosine of 135, which is your x-coordinate, you get negative radical 2 over 2. And that's how they determine their positive and negatives. There is a chart on the book. You can see which one's positive or negative, or as you can see how I highlighted here, each of the corners determine which one's positive and which one's negative. So that's for A. B. Tangent of 390, again, keep it within the circle. So subtract 360 until you get something that you can graph here. And when you do that, you end up with 30 degrees. So it's 390 or it's 30 degrees. 390 and 30, they're coterminal, meaning if you just add or subtract 360, you end up with that degree, and it's also on the same line. So we're going to be focusing on the 30. So if you look at the terminal line here, you're trying to see, is it closer to the 180, 360, or the 0? In this case, when it's in the first quadrant, that is the reference number. The reference number is 30. So in the first quadrant, it's the same number. The second, third, and fourth, that's when you have to do some subtraction. And then you have the reference number here is 30. So 30 is radical, oh, this is for the tangent, so that means you'll be dividing. So dividing y over x, which is, let me get that out real quick. It's 1/2 times radical 3 over 2. So that's the y-coordinate, that's the x-coordinate of the 30 degrees, or the 390. So when you're trying to get rid of this complex fraction, you multiply by the reciprocal from the bottom and top, which is 2 over radical 3. You end up, these cancel out, 1 over radical 3. Which you can't get. Now you get to go ahead and rationalize the denominator. You end up with, I'm sorry there's not that much space here, but you end up with radical 3 over 3. And then you're looking at the first quadrant. So 390 is in the first quadrant, and the reference number is 30, but the tangent will be there. The first quadrant, everything is positive, nothing is negative, so your answer is radical 3 over 3. Now, keep in mind reference number, remember positive, it's a terminal line, seeing whichever is closer to the x-axis, except the first quadrant, which is the same number. Now we have this. Whenever you have everything in terms of radians, you want to keep it in radians, and that's what I refer to in your homework. So here we have 5 radians over 3. If you want to make sure if it's within the circle, you can just make it into a degree form just to see if it's in the circle, not for your answer. And that is right here, which is this mark here, which is also known as 300. And then the reference number for 5 radians over 3, is this part right here. So this is a terminal line. You're seeing if it's closer to radians or 2 radians. And it's closer to radians. So we're just finding the reference numbers for these. So 5 radians. We're trying to find what that space is. So then you're going to be subtracting 2 radians by 5 radians. Again, it's always positive, so always do the bigger number first. 2 radians is considered 360. This 5 radians over 3 is considered 300. So therefore you subtract, and remember you have to make sure they have a common denominator. You end up with 6 radians over 3 minus 5 radians over 3, and you end up with radians over 3. And that is your reference number. Now your next one. B is theta is equal to 870. So 870 now within the circle. So let's go ahead and subtract. We subtracted here, we got 510. That's still now within the circle. Subtract 360 again, and I end up with 150 degrees. So now if I were to graph that, 150 degrees is about here. So this is a coterminal point. It's coterminal to 870, so I'm just going to put here 150 degrees. So now when we graph it, so they coincide here. Now the space on the terminal line is closer to the 180 rather than the 0. So if it's going this way, 0, 180, and then 360. So it's closer to the 180, so then you'll subtract the 2. So 180 minus 150, not the 870. Again, it has to be between 0 and 360. So 180 minus 150, and you get about 30 degrees. And that is your reference number. So again, it's just that space right there. When you're finding these, again, you could always look back to the chart and look for your sine, your cosine, etc., etc. But in this case, they want you to do the extra work just in case you're out doing an SAT or the ACT or SAT. If you're doing one of those, you can always apply any of these methods. And right here, we have the steps here for you. So you have the reference number. You have to find it first. You find the terminal point of the trig function. So if it's a cosine of 25 or 30, you'll just look at the reference number there, not the both coordinates, just one of them if you need it. And third one, determine if it's negative or positive depending on the quadrant. This is how they find all of these points here. They always stick with the 30, 60, 90 triangle and the 45, 45, 90 triangle. They stick with those 2 triangles to find the measurements of the first quadrant, and then depending on the region, it's positive or negative. It's all the same numbers, just positive or negative. Here, the sine of 240. 240 is within 360, so we don't have to worry about that. Let me move this camera here. So now, we have sine of 240. If I graph it, I have here. The first thing you do, you always find your reference point. Let me go ahead and, there you go. You always find your reference point here. So I shaded in that region. So this is 240. You're gonna do 240 minus 180. So either 180 minus a number or the number minus 180. You're always trying to keep it positive. And that will give you 60. So first quadrant, you have reference number of 60. Second thing, you're trying to find, you're trying to find the sine of that reference number. The sine of 60, going back to your chart, the sine of 60 is radical 3 over 2. And third step, if it's in the third quadrant, is sine positive or negative? So in the third quadrant, the only thing positive is tangent. So in this case, everything else is negative. So your answer is negative radical 3 over 2. So it's very simple, just following 3 steps, but that's how they get each of these numbers. So the sine of 240 is negative radical 3 over 2. Cotangent of 495, so we have to subtract because it's not within our chart. So 495 minus 360, I have the cotangent of 135. That's what I have drawn here. I'm going to find my reference number first. To find your reference number, that shaded region I just did, 135 is closer to the 180. So 180 minus 135, it has to be positive. And you get 45. Now you're finding the cosine of 45 degrees. So the cosine of 45 is radical 2 over 2. And then the third thing is, it's in the second quadrant. The only thing positive is the sine in the second quadrant. So that means it's going to be a negative radical 2 over 2. And that will be your answer. Oh, I'm sorry. It's cotangent. So the cotangent of 45. Let's go back to this. Cotangent means it's over here. It's x divided by y. So it's your x coordinate divided by your y coordinate. Your x coordinate of 45 is radical 2 over 2. And your y is radical 2 over 2. It's the same number. If you're dividing the same number, like 7 divided by 7, radians divided by radians, you always end up with the number 1. You can go ahead and multiply by the reciprocal top and bottom. You'll end up with the number 1. And then 3, focusing on the quadrant. It's on the second quadrant. We said earlier it is negative, so your answer is negative 1. All right, last one. So we have example 4. That's when we have these higher radians. We want to keep it within the circle, so go ahead and subtract by 2 radians. Get a common denominator. You end up with 16 radians over 3 minus 6 radians over 3, which is equal to 10 radians over 3. So remember, denominator stays the same. 10 radians over 3 is not within the circle. I'm going to go ahead and subtract again. 10 radians over 3 minus 2 radians again. So 3 over 3. So that's the common denominator. You get 10 radians over 3 minus 6 radians over 3. And you end up with 4 radians over 3. And that is within the circle. 4 radians over 3 is also considered 240. So now we're looking for the sine of 4 radians over 3. So we haven't even started with the first one. So sine of 4 radians over 3. Actually, let's not focus here. I'm going to go ahead and graph this. So 16 radians over 3 is coterminal to 4 radians over 3, which is drawn right there. So again, remember it's 240. You go ahead and shade in the region that you need to find the reference number. So that means it's radians minus, actually it's 4 radians over 3 minus just radians, because it's closer to that. Also known as 180 degrees. So get same denominator, so 4 radians over 3 minus 3 radians over 3, and the reference number is just radians over 3. Radians over 3 is also considered 60 degrees. Step 2, find the sine of radians over 3. The sine of radians over 3, remember it's the y coordinate, is radical 3 over 2. Third step, it's in the third quadrant. The only thing positive is tangent. That means it's going to be a negative. Negative radical 3 over 2, and that's your answer. Last one, the secant of negative radians over 4. It's negative, so remember we have to keep it within the circle. So I'm going to add 2 radians to it. So that means I'm going to multiply by 4 so I can get the common denominator. And then I get negative radians over 4 plus 8 radians over 4, 2 times 4, over 4. And that gets 7 radians over 4. It's positive. Remember, you're only adding and subtracting. Step 1, you find your reference number. So negative radians over 4, it's coterminal with 7 radians over 4. And this space here, you try to find the reference number, you're going to subtract by the closest x-axis number, which is 2 radians minus 7 radians over 4. Multiply top and bottom, multiply top and bottom by 4, 9. And we're trying to find the reference number. So we did this to find a number within the graph here. Now we're finding the reference number. So we get 8 radians over 4 minus 7 radians over 4. And if you see, you have just radians over 4. Radians over 4 is considered 45 degrees. But we're keeping everything in radian form. Step 2, they want you to find the secant of radians over 4. Secant is considered the reciprocal of the cosine. So cosine of radians over 4, cosine is your x-coordinate, so radical 2 over 2. So that's the cosine, so that means you flip it. So that means you get 2 over radical 2, because it's secant, so you flip it. But then, you can't have radicals in the denominator, so you end up with 2 radical 2 over 2, which cancels out, and you're left with radical 2. Last step, you're trying to see if it's positive or negative. So this was in the third quadrant. So here it says cosine and secant is positive. So therefore, it's positive. So therefore you end up with that. But again, you have the chart in front of you. I just want to show you where you get it from, just from understanding the 2 special triangles. Have a good day.